Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, in our today's video, we will discuss about the ideal gas constant that is denoted by R. Now, here we will find the values and the units. So, what is the main motive for our today's video? Main objective is we have to calculate the values and units for R, where R is known as the general gas constant. So we have the equation main which is product of pressure and volume P into V is equal to product of number of moles, general gas constant and the temperature. So here we just gain that equation which is PV is equal to nRT. Now how we can calculate its value? Basically here we will use the Avogadro's principle. So Avogadro's principle helps us to calculate the values of the R, and its all values basically depends upon all the units that we will use for pressure, temperature, volume. So its value basically depends upon pressure, temperature and volume, the units that we are going to use for this purpose. So let's derivate the value of the R. In the first one, we have to rearrange that equation which is PV is equal to nRT. It is a general gas equation that we have derived by applying all the gas laws. So we have to calculate it by applying different gas laws. So in the first we have to rearrange this. We have to just separate out the value of R, where R will be equal to PV over N into T. So this is the main equation. Now we have to just put up the values for the units. So in the first, the pressure that we take, it will be 1 atmospheric pressure or 1 atm, and number of moles we will take, it is equal to 1 mole. And here the temperature that we take, it is 273.16 Kelvin, which is equal to 0 degrees Celsius. And at the end we have to take the volume. It will take in dm cube, that is 22.414 dm cube. So we will calculate it by putting up all these values. So let's see what we gain. R is equal to pressure, which is 1 atm. Then we have volume, which is 22.414. Its unit is dm cube. Dividing it with the number of moles, which is equal to 1 mole, and multiply it with the temperature, that is 273.16. So here the value for that we gain, it is 0.0821. So unit we have, it is dm cube atm per Kelvin per mole. So this is the unit that we gain. Now what does mean by this value? Basically, when we take the pressure in 1 atm cube and volume is 22.414 and number of moles is 1, and the temperature we will take, it is almost 273.16 Kelvin, then its physical means that it absorbs the amount of energy that is equal to 0.0821 dm cube atm per Kelvin and per mole. So this is the basically amount of energy that any gas will absorb when we apply the conditions in this unit. So this is the value that we have to find. Next we have if the units of pressure changes, or all the units that we are going to change. So here we have to change the unit of pressure, temperature and volume. Then what is going to be happen? In the first, if we take it liter atm per mole per Kelvin, then the value is 0.08206 that we have just calculated. But when we just take its value in joules per Kelvin per mole, then the value is 8.314. After that, if we take its value in Kelvin calories per mole per Kelvin, then its value is 1.987. When it is meter cube Pascal, which is pressure mole per Kelvin, then the value is 8.314. And when we changes the volume into liter and pressure into torr, and the unit of moles and temperature will be same, that is mole per Kelvin. So the value is 62.36. We can calculate all these values by putting up the values in this unit. So here, if we are going to change the units of the pressure and temperature, in turn the value of R or the general gas constant is also changes, as just its unit changes, not the value. Basically, the main term, it will remains the same. So next we will calculate it by applying the SI units, that is known as the system international units. So the system international unit for pressure, for temperature, for volume, and for number of moles. What is the value for this? So the pressure that we take, it is atmospheric unit, is almost equal to SI, which is we have 1 atm. 1 atm is equal to almost 760 torr, and 760 torr take it is equal to 101.325 Newton per meter. So this is the SI unit, Newton per meter square. Then temperature is in Kelvin, that is 273.16 Kelvin. The volume we take, it is in dm cube, 22.414. It is dm cube. Now by converting it into the meter cube, we gain 0.022414 meter cube, and then the number of moles, it will be same, is equal to 1 mole. Now we will calculate which is R, and the value of R we have is PV over N into T. Now we will put the values. So here the pressure we have, it is in Newton per meter, which is 101,325 Newton meter square. It is also equal to Pascal or the kilopascal. So multiply it with the volume, and the volume we have in meter cube 0.022414 meter cube, divided it with 1 mole of gas. Temperature is 273.16 Kelvin. Now at the end, the value we gain for the general gas constant, it is 8.3143 Newton meter per Kelvin and per mole. And here, if we have 1 Newton meter, that you need to remember, if we have 1 Newton meter, it is equal to 1 joule. So we can also write it like 8.3143 joules per Kelvin and per mole. So this is the simple result that we gain, or the values of the R at standard temperature and pressure. I hope you guys understand. And if you have any queries, you may ask me about it in the comment section, and I will get back to you guys soon. And the next topic will discuss about the density of an ideal gas. So for that time, you guys keep learning and have a good day.